Today we're going to learn how to build an image search engine or a semantic image search engine in Python by using a multimodal embedding model. So the idea is we have a database full of images, we can label them, but we don't have to label them, and then we can type a search query, like for example, red car. And then we're going to get all the images that match red car, even though we didn't have to label the images in the first place. This works because we're going to use a multimodal embedding model, so text and images are going to be embedded in the same vector space, and thus we can easily do a similarity search. If you like this video, let me know by hitting a like button and subscribing, but now let us get right into it. Alright, so we're going to build an image search engine in Python today by using a multimodal embedding model. To be precise, we're going to use the jina-clip v2 model. There is a link in the description down below where you can find this on Hugging Face. And as I already mentioned in the introduction, the idea of a multimodal embedding model is that we have different modalities embedded in the same vector space. So we have images and text embedded in the same vector space, which means that we can look for images by doing a similarity search using a text query. So maybe to visualize this very briefly here, in a vector space, let's say we have a three-dimensional vector space, which is of course not realistic because these embedding models usually have thousands of dimensions. But the idea would be that, let's say I have a text vector space and I have the concept of king. I have the word king. And king could be somewhere here. So very high up this axis, not so high in this direction, not so much in this direction. And now I have the word queen, for example. So this would be something maybe if we just follow this line here over here. So it would be the same height. We could say that this is then the axis of majesty or royalty. But this one here could be the male-female axis. Now, of course, in the embedding space, we don't have labels like this, but the idea is that concepts that are quite similar are going to be close to one another. So maybe something like dog would be somewhere else, somewhere over here or something. So you would have this very high dimensional vector space, and similar concepts, similar words would be close to one another. Different concepts would be further apart from one another. And the idea now of a multimodal embedding model is that we're doing this with images and text in the same vector space. So this here could be the word king, this could be the word queen, but then here maybe I actually have an image of a king and an image of another king and the image of a queen or something like this. And the idea of a multimodal embedding model or embedding space is that we can now look for these images by providing a text query. So if I have a bunch of images of kings here, then I can just make a text query like large king or tall king, and then it would hopefully find the tallest king first and then two other kings maybe if I have top k being equal to 3. So I'm looking for the top 3 matches. Then I would type something like king or tall king or handsome king or something like this, and I would get the 3 images that match this query the most. That is the idea. This is what we're going to do in this video today. And this can run on very weak hardware because right now I'm running this on a laptop, which is quite old. And there's a reason I'm coding on my laptop because I'm going to be in a different location soon where I'm only going to have my laptop. So I'm coding on this here to see if this actually works with the recording setup. But as you can see here, what I have is I have a Core i7, a very old one. I have a dedicated GPU. I think it's a 550X old GPU, but we're not even going to use this one. We're mainly going to use the RAM, and I have 16 gigabytes of RAM here. So this is a very old machine. It's a ThinkPad E590, but I'm still going to be able to run this. I'm not sure if I'm going to be able to run this while recording, but this search engine will also run on this old hardware. So you don't need to have a beast in order to be able to replicate this. All right, so let us get into the building phase. Let's move to a directory where we want to be working in. And here now I'm going to use UV to set up my project. You can also do that with your system Python installation by just saying pip or pip3 install. I'm going to do UV init to create a new project here, and I'm going to use UV add instead of pip install. And we're going to need quite a few dependencies here. The most important one is going to be Hugging Face transformers. So transformers is going to be the package, also sentence underscore transformers. Then of course also torch, and we're also going to need Qdrant, or actually Qdrant client. This is a vector store, a vector database. The idea is we want to store the vectors somewhere, and Qdrant has very nice features. We can just add stuff to it like tags or filtering criteria, and we can work with this in a very flexible way. So this is the one that we're going to choose here. Then we also need Pillow to be able to work with images. And I think we're going to have to explicitly install some modules. I think they should to some degree be installed automatically, but I'm going to install einops. Not sure how this is pronounced. einops, something like this. Then also TIMM, and I'm pretty sure requests will be installed automatically, but let's do that. So this is now going to install the packages automatically. One thing that's important here is that we need to specify, or we need to constrain the version of sentence transformers. At least on my system, it produces a problem because of a dependency issue, so we're going to have to adjust this manually. All right, so once this is done, we're going to open up the PyProject toml, and here we want to constrain the sentence transformers to not be this version, but to be actually below version 5. So actually, I'm going to say here that this shall be above 4.1, or what did I have in my actually above or equal to 4.1? And I want it to be less than 5. And I'm going to do the same thing for the transformers. So here it's going to be greater than or equal to 4.45 and less than 5. Save that. And then we can say UV sync. You can see that the versions were updated and this should now work. So let us get started by activating the virtual environment. So source venv bin activate, and then we're going to open up main py. I'm going to delete the code that's already here. I'm going to go full screen. I'm going to zoom in. And now we're going to build a basic prototype. The goal is to first build the proof of concept to understand what we're doing, and then to wrap this around or to wrap a Flask application around it. So we have a web app, and then you can easily style this with your favorite coding agent. Just use Claude Code or something else to add some CSS, JavaScript, and everything around it. I'm also going to show you later on a more advanced version of this on my GitHub, where I invested a little bit more time. So let's start with the imports. I'm going to say import OS, import random, import torch, so PyTorch. From Pillow, import the image. From sentence transformers, we're going to import the sentence. Actually, where's my autocomplete? Sentence transformer class here, or module. And then we also need Qdrant. So I'm going to say here from Qdrant client, import Qdrant client, and then also from Qdrant client dot models, we're going to import vector parameters, distance, and the point structure. I'm going to explain why we need all of these in a second here. But these are the basic imports. Now, the first thing we want to do is want to set the device to be a GPU if available. So we're going to say CUDA, if CUDA is available. So if torch CUDA is available, we're going to use the GPU. Otherwise, we're going to fall back to the CPU. So on this system here, since I'm using my old laptop, we're going to fall back to the CPU, but you're going to see that this is also possible and doesn't really cause a huge slowdown. Then we need to use the model. We need to download the model. So I'm going to say model equals to sentence transformer. And now we need to provide the correct handle. So that would be this part here. So we can just copy it from the URL. That would be the model, the Hugging Face repository, so to say. We're going to say trust remote code equals true. Truncate dimension, let's go with 1024. We're not going to need that much. And then, of course, don't forget to set device equal to the device that we chose in the beginning. So either CUDA or the CPU. So this already is a model that allows us to do embedding. So I'm not sure what the function was named exactly. I think it was something like encode. Yeah, encode basically. And here now to this encode function, we can either pass an image or text data. And then we can also normalize, and that is all going to happen in the same vector space. This is already enough on the embedding side. Now we also need to handle the vector store. So we need to create it. We need to fill it up with images. If we want to use some images that we already have, we can fill it up with images. And then we can also load it in case it already exists. So for that, I'm going to say here, if not os.path.exists, and we're going to provide here the path image store. So if that doesn't exist, we're going to set up everything from scratch. Otherwise, we're just going to load it afterwards. So otherwise, we're going to say client is equal to Qdrant client, and the location is going to be image store, specified by path here. So path is equal to image store. Now, interestingly, we're going to do the same thing also if it doesn't exist, but this function automatically either loads or creates this directory. So if it doesn't exist, it's going to be created by this command. Otherwise, it's going to just be loaded. So we need, in both cases, this command, but the rest is going to differ. And also the order is going to differ. So here we create first, and then we do the setup work. And in this case, we just load. And the reason we cannot just do it beforehand is because if I run this, I'm not going to be able to check if the directory exists, because then it's definitely going to exist. So that's the reason why we do it this way here. Then I also did something else. If we go to the tutorial directory again, I have here a directory full of images. Now you can choose whatever images you want here. I'm not going to be able to provide them to you, because if I provide them to you, I'm going to be infringing on some copyright, I guess. But basically we have some images here. I also have some stuff that I added afterwards, but basically we have some fruit, we have some motorcycles, some people, some flowers, some dogs, some cars, some planes, and all that. Let me remove the custom uploaded images. That is going to be the database that I use. So the first step is to take these images and load them into the vector store, and then later on we're just going to use them for the querying as a basis for the querying. But you can fill this directory up with whatever you want. In my case, I just have a directory called images, and in this image directory then I have all these images, and the naming isn't that important. All right, so let's get all the images here. For the embedding, I'm going to say os path join the images directory and then the file. So let's call it F. For F in OS list dir, and we're going to list all the files and images. So the idea is I'm going to just get the file names here, and then we're going to join them with images. We have the full path or the relative path to that directory, and then we're going to use that for the embedding. So then we're just going to say embeddings, or we can also call this image embeddings, but let's just call it embeddings. It's going to be model encode the image. Then we're also going to specify normalize embeddings true, device equal device for image in images. So that's just going to create the embeddings for every single image. And all of this is still not touching on Qdrant. So the next step now is to actually create the collection in a Qdrant vector store and to then persist it on the disk. I'm going to say client, which is our Qdrant client that we created here. Client recreate collection name is whatever you want it to be. I'm just going to go with images here. And then important, we need to specify some configuration stuff. So we need to specify the dimensionality of the vector store and also the distance measure. So for that here, I'm going to use vectors config. And for this, we have to pass an instance of vector params. And as I said, the first thing is the dimensionality. So we're going to say size is equal to length of embeddings 0. So that is going to give us the size of a single embedding. That is going to be the size of every embedding, since we have the same dimensionality for all of them. And then I think the keyword was distance, was it? Yeah, distance is equal to distance.cosine. So cosine similarity here. So this creates the collection. Now we need to fill it up. For this, we're going to say client.upsert. And I noticed that I didn't properly close this. So actually we need to add a closing bracket here. Then we say client upsert. Again, collection name is equal to the same, which is images. And now we need to pass a list of points in this vector space. So the points are going to be a list, and the list is going to be full of point structs. So point struct is the class that we imported up here, point struct. This point struct will have an ID. I'm just going to go up here and say, in addition to this, import UUID. Then I'm going to jump back down. The ID is going to be some randomly generated UUID4. The vector that we want to put in here is going to be embeddings I. And then we also need a payload. The payload is going to be the path. So we want to also have the path. Why do we want to have the path? Because we're not just interested in embedding the embedding. We also want to know, okay, what image is this actually? What image does this actually belong to? So I can then retrieve it and show it to the user. So I'm going to add here a field path, which is going to point to the path of the image that is embedded. So images index I. And all of this for I in range length images. So for every single image, we're going to do that. Cool. And after all of this, we can say done so that we know that we're actually done with this, just as a status message for us for debugging. And to test this, we can give it a try. We can say the search query is equal to user input. So the user can provide something, enter query. Then we can use the same method for embedding. So we can say query embedding is equal to model encode. And we can encode the search query. normalize embeddings true, device is equal to device, same as for the image, as you can see. And to make sure this is not blocking, my camera is not blocking this, let me just move this a little bit here. So that is going to be the query embedding. And then we can just do a similarity search to get the top 5 results. So I'm going to say here results is equal to client.query points. Collection name is going to be images. Query is going to be our embedded, or actually, what did I call it? Query embedding. And the limit is the top case, so to say. So limit equals 5 means we're looking at the top 5 matches, and we need to get the points. So we're interested in the points. These are the results. And then we can just say here, print for every one of them, a list comprehension here, r dot path, for example. So r path like this, or actually, sorry, it's our payload path, because remember, we're passing this as a payload. This is the dictionary, so the dictionary is payload and path is a field in it. That for r in results. Let's see if I made any mistakes. We can run this uv run main.py, and this will take some time the first time we run this. Okay, so I have a typo, which shouldn't be that much of a big deal. I imported vectro params instead of vector params. So let's just fix that. Did I also use the incorrect one? Where did I actually do that? Vectro, yeah. Let's go vector params, uv run main.py. All right, so after quite some time it finished. There is something that we should change probably, which is that after this if statement, we create a second client, which means that if we run this the first time, it's going to create the store and it's going to also try to connect to it again. So instead of doing that, we're just going to add an else here so that we don't have to create a client twice, because that leads to an exception. Besides that, I think this should now work. So if I say uv run main.py, I should be able to enter a query and get the images as a result. So for example, if I enter now red car, I should get the path of the top 5 matches, which are image 302, 313, 329, 322, and 328. So let's go and do nomax and then images, image 302 JPEG. That is a red car. What was the other one? 313. Yeah, I mean, I'm not sure if this is entirely red, but maybe that's the best match that we have. Okay, so this proof of concept works quite well. Now let us move on and create a Flask application around this. So I'm going to actually create a new file here called Flask application, but also I want to add Flask here. So I'm going to say uv add Flask, and then just let's create Flask app.py. Now some of the stuff can just be copied, so let's open up main.py and copy what works. So I think this portion here will stay roughly the same. Maybe we don't need all of it, but essentially we still need to load the model. We still need to decide on the device, and then we're going to do everything like the inference and the uploading through Flask endpoints. So I'm not sure if we're going to keep all of this. Maybe we're going to remove some stuff, but now let's say from Flask import Flask render template, and I think I need to activate my environment again. Source venv bin activate, back to Flask. So render template, requests is also something that I want to import here. And we're going to start with a simple index endpoint, or first of all, we're going to define the application. So the Flask application will be an instance of Flask. Then we're going to say static folder is going to be images, because we want to be able to serve the images to the user. We want to actually render the image in the browser instead of just returning the path. And I'm going to say static URL path is also going to be images slash images, of course. So then we're going to define our first route, app route, which is going to be the default route, and that's going to be our index function. This index function will render a template, but for now we're just going to pass. And also, of course, one more thing that we're going to need from main.py is the creation or the initialization of the Qdrant client, because we're going to use the vector store we just created. So we're going to use the one that we already created, but we're also going to be able to upload new stuff to it. Now, in addition to the index, I also want to have two endpoints, one for searching and one for uploading. So I'm going to say here app route, and here we're going to upload now a new image with the ability to also specify manual tags. The idea is that I can, of course, rely on the embedding model to recognize that this is a red car, but sometimes maybe a person has a name and the model cannot know that name. And because of this, I want to also allow the user to enter specific manual tags. So we're going to have an endpoint here, upload image. It's going to accept post requests only. So methods is equal to post, upload image, and then pass. And then also we're going to have search query, of course, with a leading slash. And that's also going to have methods equal to post. So search query and also a pass here. So this is the basic structure. Now, what's the idea here? Actually, our idea is that we're going to render a basic HTML page on the index route. So I'm going to say here return render template, and that's just going to be an index HTML. But also we want to be able to upload images so that they're inserted into the vector store with their embedding, or their embedding is inserted into the vector store, and they're also stored as a file in the static image folder. And then we want to be able to do a similarity search with top k equals to 5. And then we want to just see the images that are the closest matches to the query. So for this, in the upload image endpoint, we need to get the file that was uploaded. So we're going to keep it simple, just one file per upload to have a basic version that works. So request files, and then here we're going to get the image file. We're going to naively assume that it's always passed. We're not going to check here. And then also the tags. And for the tags, I'm just going to match for the exact same string. As I said, I'm going to show you a more advanced version later on here in the video, and you will also get a link to the GitHub. But for now, let's just keep it simple and react to exact matches. So request.forms or form, and here we want to use get because we can have an empty value, and the get is going to be image tags. And we're going to fall back to an empty string. Then we're going to say image path is going to be equal to os path join, and we want to join the static directory images with the file name. So file.file name, the file name of the uploaded file essentially. And then file save. We're going to save the file that was uploaded here to the image path. Now this just means that the file is now in the directory. We don't have the embedding yet. So we're now going to say embedding is equal to model encode as before. The image data. Now, what is the image data? We need to first open the image. And now, of course, the file exists on the disk, but we don't have the embedding yet. So I'm going to say here embedding is equal to model encode image path, same as before, normalize embeddings true, device is equal to device. So now we have the embedding, and now we just need to add this embedding to the vector space with the tag. So now we're going to include in the payload, not just a path, but also a list of tags, or in our case, it's just going to be a string, comma separated. And yeah, you can, of course, make this better, but we're going to say client upsert, same as before. Collection name is going to be still images, and then points is going to be equal to a list of point structs, where the ID is going to be a UUID4, so basically unique. Vector is going to be the embedding. And now, as I said, the payload is going to be a dictionary with the path still there. So the path is still going to be the image path, but now we also want to have tags, and the tags are going to be whatever the tags are. That's basically it. We do need to return something, or we should return something. So let's just return the string success. This is not a professional web application. We're not going to style it very much, but that is our upload endpoint. Now for the search query, we're going to do something similar. I'm going to say query is equal to request form, and we're not going to do get. We're going to do the access directly here to query, and then we're going to embed it immediately. So embedding is going to be equal to model encode query, same as before, normalize embeddings true, actually with uppercase T, and then the, what was it, device is equal to device. That is now the embedding, and now we need to just do the similarity search and render the images. And now we need to do something slightly different because we do have the tagging system now. And you can design this however you want, but in my opinion, it makes sense that if you explicitly tag something, and you have an exact match, that you get these first. So what we want to do first, we want to query the vector store for exact matches on the tags. And then we're going to fill the rest up with similarity search on vector basis. So what I mean by that is we're going to craft a tag filter. Now for that, we're going to need, I think, additional imports here. So we're going to go back up. And in addition here to those things, we're going to also import filter and field condition. And what was the other one? Match value. So we're going to craft a filter. We're going to apply this filter. The filter is just going to be a filter, and we're going to specify a must condition. So it's going to say that something is required in this must condition. And these must conditions here are going to be field condition. We're just going to have a single item here. And the field condition is an exact match on the tag. So that's going to be our first iteration. Then we're going to fill up. So if we find 2 exact matches, we're going to have 3 left to fill up to 5. And if we have 0 matches, we're going to have top 5 as before. So the key that we're focusing on is tags. We're looking at the tags of the payload, and we're requiring an exact match. So match is going to be equal to match value, where the value is going to be the exact query. So if I tag an image with, I don't know, Florian, and then my query is exactly Florian, then that should be an exact match. So that is the filter. Then we can say tag results is going to be equal to, and now we're going to just do the client querying. So query points as before. And we're going to say collection name is equal to images. Query is still going to be provided because we can also have more than 5. And then we want to have the closest matches from this filtered set. So embedding. So what I mean is you could have like 10 images of Florian and you provide Florian, but then you want to also maybe get the closest matches on an embedding basis. And this makes sense, of course, if you don't just, if you have parts of the query being enough to match and all that stuff. But yeah, let's keep it simple. That's going to be our mechanism here. Now we need to specify here query filter. And query filter basically means that this is going to be applied. So our must condition will be applied. Everything that is not an exact match will be thrown out of the result set. And still the limit is going to be 5, and we're interested in the points. So these are the tag results. Now we're going to get the rest of the results, and these are just going to be client query points. Actually, we can copy this. We just need to remove the condition. So let's say results are going to be equal to query points, images, query embedding, get rid of the filter, and now the limit is going to be the remaining length. So we're going to say maximum of 0 and the length of, or actually 5 minus the length of the tag results. So that should work. These are the points. And now basically we have 5. If we have enough matches overall, if we have enough content in a database, we should have 5 matches. But of course, we still have the problem of duplicates. So let's say I find 3 here, but I then find also the remaining 2 here, and one of them is a duplicate. So we want to get rid of this possibility of duplicates. We're not going to fill up to 5 no matter what, so this would be a little bit more complicated then. But I'm going to just say here final results are going to be the tag results. And then I'm going to say for result in results, if are not in final results, we're going to say final results append are. And then finally, I'm going to return the render template of, again, index HTML. And the results are going to be a list comprehension, R, payload, and then path. So we're just transmitting the path to the front end, because in the front end, since we have static images, we have a static image directory, we can just use the path to access the images. So that for R in results. That's that. So I think if I didn't make any mistakes, that should work now. So I should be able to just say down here, if name equals main, we should just do app run. I wouldn't do debug true because then it would get into an endless loop. So let's say debug equals false. And what we also need is we need a template directory. So I'm going to say here, make directory templates. And in this templates directory, I'm going to say index.html. And here now we can craft a basic HTML file. So this is the basic structure snippet here. And in the body section, we're now going to have 2 forms. One is going to be for uploading, one is going to be for searching. So I'm going to just say form, method is going to be post, method post, there you go. Action has to be /upload image. Then we have the enc type, which is multi-part form data, since we're going to upload files here. Then we have an input type file, which is going to be the image file. We don't need a value for this one. And then we have also the tag. So input, actually, let me use input like this here. Input type text, image tags. We don't need a value either. And then button type submit with upload as the text here. So that's the first form. The second form is going to be for the querying. So it's also going to be post, but it's going to be for /search query. We don't need this encoding type here. We're going to have the name query, and we're going to just use text, and the text is going to be search. Now, the only thing left here is to list the results. So to show the images, that can be done easily with a loop. So here we're going to say if results. So if we do have results, then we of course need to say end if, and then I'm going to say for R in results, and we can of course also close this with an end for. We're going to have an image tag, and the source is going to be the path to the image. So / and then R. Now I also want to specify that the width is 300 just to keep it smaller. We don't need an alternative text. And I also want to have a line break. That is it. That should be it. So maybe I made some mistakes, but if not, this should now work. Let's see if the basic prototype here works. Let's go and say uv run flask app.py. Server is running, so let's open this. And there you go. We have this interface here. Maybe I can choose a file. So I do have a directory here with two images. One is a wizard, one is a panther. So I can go with the wizard one and I can just upload without a tag. Let's see if this works. This is now embedded if it works properly. There you go. Took some time, but we have success. Now if I reload this and I type wizard, I should be able to get it hopefully as a first result. Okay, yeah. So I get two cats, two guys that maybe look like wizards a bit, and then my wizard image as number one. Now let's try something else. Let's go with the panther, but this time I'm going to give it a tag, and the tag is going to be neural 9. So I'm going to upload this. Success, there you go. And now if I type neural 9, I should get the panther first, even though it probably wouldn't be first by default. But I don't get it. Interestingly, I get a black cat, which is, I think, a coincidence. Doesn't have to do anything with the panther. But I realized what the problem is. The problem is here I'm iterating over results, not over final results, which is actually what we're crafting here with the tag results. So I'm just getting the non-tag results, which of course makes sense that I don't have the tagged result in there. So run Flask app again. Okay, now if I type neural 9 again, I should get the panther as a first result. There you go. We have it as a first result because the tag was an exact match. Now, the last thing I wanted to show you here is a more advanced version of this. This is a repo I have on GitHub called latent assets or latent assets. I still don't know how to pronounce this correctly. But essentially, this is the same idea, but we can provide multiple tags. We have a nice user interface. And of course, this is still in development, but basically you just clone the repository. You can run these commands and then you have the system. This is now on fast API basis with a front end, with a React front end. But this is basically the same thing, but more mature. So here I have it on my system. I can just cat the README to see the commands. Then I can run the inference server here. I can open up another terminal, cat the README here as well. Then I can run the backend, which is going to use this inference server, and then cat the README again. And finally, we can run the front end after running an npm install, of course. So now front end is running, backend is running, inference server is running. Yeah, so this seems to be a bit too much for my laptop here, but you can see the idea. I can just upload an image here, like the wizard, for example, and then I can type something like magic, comma, and then, I don't know, fantasy or something like this. And then I can upload this to the vector store. And now I think I only have a single item in here, but if I type wizard, I should be able to find that as the only image, obviously. There you go. But if I type, for example, magic, I should also find it with an annotation that this is actually an exact match for the tag. They can see tagged. And then I can also edit the tags here. So this is just a more advanced version of that. You can look at the code if you're interested in that. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a tutoring tab and a services tab. There you can contact me if you need help with a project from a freelancer, if you need some consultation, or if you want me to teach you something one-on-one. You can contact me at the bottom via LinkedIn or via email. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.